All right, hey guys, so we are going to move forward in chapter 4, moving on to lesson 4.5. So let me present my screen and we'll start. Okay, so in lesson 4.5, we're going to be starting by talking about repeated solutions. Okay, we're still solving polynomial equations, but we're going to learn another method of solving polynomial equations. So to start with, repeated solutions, and you've heard me refer to some solutions as double roots, and we're going to talk more about that today. So repeated solutions, a solution of an equation that appears more than once. The equation x plus 2 squared equals 0 has a repeated solution of -2, okay? Then we have something called the rational roots theorem. We're going to be using this probably in day 2 of this lesson. Yeah, I believe day 2. This is a 2-day lesson, by the way. So we'll talk more about this in the next video lesson, but I'll just quickly read it. If f of x equals a sub n times x to the n plus, so if it's a polynomial function is what that's saying, with integer coefficients, then every rational solution of f of x equals 0 has the following form. P divided by Q. P, that is the factors of the constant term, and Q represents the factors of the leading coefficient. All right, so we're going to set up all these little ratios, these little fractions, and those are going to be possible solutions of our polynomial functions. Okay, so we're going to be using the rational roots theorem in day 2 of this lesson. The irrational conjugate theorem. Let f be a polynomial function with rational coefficients, and let a and b be rational numbers such that the square root of b is irrational. If a plus root b is a 0 of the function, then a minus root b is also a 0 of the function. This irrational conjugates theorem, again, will be discussed in more detail in day 2 of this lesson, okay? So the first set of problems, it says solve the equation by factoring, and then I have my little hint here, set each equation equal to 0. So if we're going to solve, and some of them are already set equal to 0, if we're going to solve, the first step is to set it equal to 0, and then we're going to try to factor. So let me get my pen set up here. All right, so the first equation is already set equal to 0. Now, if you remember from our previous lessons, the first step of factoring is to look at that GCF. What do the two terms have in common? They have an r in common. So I'm going to factor out that r. I'm left with 36r squared minus 1. Now, inside the parentheses, I count my number of terms. I have 2 terms. The only way to factor 2 terms is if it is a pattern, a difference of perfect squares, or it could be a difference of cubes or sum of cubes. This is different to perfect squares because both terms are perfect squares. So it's going to factor to 6r minus 1 and then 6r plus 1. Once you're in complete factored form, you then set each factor equal to 0. Because notice, everything's being multiplied together. This factor is being multiplied by this factor, which is being multiplied by this factor, and it says it's equal to 0. Well, the only way to multiply and get an answer of 0 is if one of these, at least one of these, is 0. So you're going to set each factor equal to 0. It's a zero product property. And then you're going to solve for r. Okay, so the first equation, there are no other steps. R is equal to 0 is one of your solutions. I'm going to add both sides. I have 6r equals a positive 1. Divide by 6, r equals 1/6. For the next one, I'm going to subtract 1 from both sides. So 6r equals -1. Divide both sides by 6, and I have r equals -1/6. All right, so those are the solutions. Those are the answers to the problem. Okay, so problem number 2, actually, I'm just going to delete this, give myself more space. So for problem number 2, I need to set it equal to 0. I'm going to move that 60x to the other side by adding it, and I'm going to put it in descending exponent order so that we start with the highest exponent first, 20x cubed. then I'd have plus 80x squared, then moving that 60x over by adding it, so 60x equals 0. Solve by factoring, look for a GCF. The GCF is a 20x, so I'm going to factor out a 20x. I'm left with x squared plus 4x plus 3. Excuse me. I have a trinomial, so I'm going to try and see if that can factor into two binomials. Reverse FOIL, guess and check. So what two numbers multiply to give you a positive 3 and add to a positive 4? You're going to have a 3 and a 1. Once you're in complete factored form, you set each factor equal to 0, the zero product property. So if 20x is equal to 0, I have x plus 3 is equal to 0, and I have x plus 1 is equal to 0. And divide both sides by 20 to solve for x, and I have x equals 0. Minus 3, subtract 3 from both sides, and I have x is equal to negative 3. Subtract 1 from both sides, and I have x is equal to negative 1. All right, before I move forward, I didn't point this out in the last problem, but I'll write the solutions back up here again so we can talk about them. So for the first problem, these were my solutions. All right, so before I move forward, what is the degree of this polynomial? Degree 3, right? How many solutions are there? 3 solutions. What is the degree of this polynomial? Look for the largest exponent, it's degree 3. How many solutions are there? 1, 2, 3. Okay, just notice that because we're going to talk about that in just a moment. Let's move on to problem number 3. Okay, so still setting equal to 0. I like to factor with the positive lead coefficient, and since my 75m to the 4th has the highest exponent, I'm going to subtract the 3m squared to the other side. So I have 0 equals 75m to the 4th minus 3m squared. Now, if you want to rewrite it and write it as 75m to the 4th minus 3m squared equals 0, you absolutely can. Okay, so you're still looking for the GCF to start. You have a GCF of 3m squared. When you factor that out, you're left with 25m squared minus, and this is where I see mistakes occasionally, when you're pulling out the 3m squared, remember, you're really dividing by 3m squared. So 3m squared divided by 3m squared is a 1. Only 2 terms. The only way to factor 2-term polynomial is if it is a difference of perfect squares, a difference of cubes, or a sum of cubes. This is a difference of perfect squares, so it's going to factor again. It's a 5m minus 1 and 5m plus 1. I'm going to set each factor equal to 0, so I have 3m squared equals 0. I have 5m minus 1 equals 0, and I have 5m plus 1 equals 0. All right, divide both sides by 3 here. You're going to have m squared equals 0. And then, just get rid of this little thing here, give myself a little more room. Then take the square root of both sides. So you're going to have m is equal to, it would technically be plus minus square root of 0, but 0 either positive or negative. Right? So we don't really do that part. We don't do the plus minus, but that's typically the next step is to take the square root of both sides and don't forget your plus minus. But in this case, m is equal to 0. All right. The next one, we're going to add 1 to both sides. So you have 5m is equal to positive 1. Then divide by 5, m is equal to 1/5. And then subtract 1 from both sides, so 5m is equal to negative 1. Divide by 5, m is equal to negative 1/5. All right, so this is where we're going to have to think a little bit more about that connection I was talking about before. So this polynomial is degree 4, but it breaks kind of the rule for the other 2, right? It only looks like there's 3 solutions, right? But that's because this one here is what we call a repeated solution. It's a double root. And it's because, remember when I did that whole plus minus the square root? So typically when you're solving by square root, you end up with two solutions, right? Because you do the plus minus. But since 0 is not positive nor negative, right? We don't do plus minus. But this really represents two solutions. It's a repeated solution. So it is degree 4. And because this is a repeated solution, it represents basically two answers, and then answer 3, answer 4, it still meets the criteria that I talked about in the last two problems. Okay, let's keep on moving. Okay, more of the same for these two. So setting it equal to 0, I'm going to add the y to the 4th to the other side. So I have y to the 4th minus 13y squared plus 36 equals 0. All right, I'm going to try to reverse FOIL to factor this one. So I'm going to have y times y equal, or sorry, y squared times y squared equals y to the 4th. Two numbers that multiply to 36 and add to a negative 13, we're going to be using a negative 9 and a negative 4. Look inside the parentheses. There's only two terms. The only way to factor two terms is if it is a difference of squares, difference of cubes, or sum of cubes. This is a difference of squares, and so is this one. So they both factor further. You're going to have y minus 3, y plus 3. Then you're going to have y minus 2, y plus 2. Hopefully you guys are remembering your factoring skills from Algebra 1. You're going to set each factor equal to 0. So y minus 3 equals 0, y plus 3 equals 0, y minus 2 equals 0, y plus 2 equals 0, and you're going to solve each for y. So y equals 3, y equals negative 3, y equals 2, y equals negative 2. Notice you have 4 solutions, and our polynomial was degree 4. Okay. All right, the next problem, setting it equal to 0. So I have 2x to the 3rd minus x squared minus 2x plus 1 equals 0. There is no GCF. I count my terms 1, 2, 3, 4. There are 4 terms. I'm going to try to factor by grouping. I'm going to group the first 2 terms together. Put a plus sign, group the second 2 terms together. The GCF of the first 2 terms is x squared. So I have x squared pulled out, leave me with 2x minus 1. The GCF for the second 2, I'm just going to pull out a negative 1 because I'm noticing 2x, 2x, 1, 1. But this 2x is positive, this is negative. This 1 is negative, this one's positive. So if I factor out a negative 1, it just changes the signs inside the second set of parentheses, right? Dividing this by negative 1, dividing that by negative 1 will leave you with positive 2x minus 1. And that's the goal, because when we factor by grouping, we're looking for that common binomial factor. So now if I look at the problem, my GCF is actually this binomial. Okay, so the GCF is 2x minus 1. What's left over when I divide this term by 2x minus 1? I'm left with an x squared. What's left when I factor this term by 2x minus 1? I'm left with just this negative 1. Now, before you say you're done, okay, look inside sets of parentheses. No GCF here. This does not match any factoring patterns. It can't be factored. No GCF here. It is a factoring pattern. This is a difference of perfect squares. So I'm going to factor that one more time. It factors to x minus 1, x plus 1. I'm going to then set each factor equal to 0. I'm going to bring it up here because I'm running out of room. So I have 2x minus 1 is equal to 0. I have x minus 1 is equal to 0. And I also have x plus 1 is equal to 0. Solving this equation for x, add 1 to the other side. So 2x equals 1. Then divide by 2, x equals 1/2. Add 1 to the other side, so x equals 1. Subtract 1, so x equals negative 1. There are 3 solutions, and our polynomial had degree 3. Okay. The last one of this type. All right, so setting it equal to 0, I want my lead coefficient, which is the highest exponent. So my lead coefficient, I want to be positive. So I'm going to leave the 8c cubed on the right-hand side and move everything to the right-hand side so that my lead coefficient is positive. So I'm going to have a positive 8c cubed. Then I'm going to move the negative 20c squared over by adding it. So plus 20c squared. Then I'm going to move my 50c over by subtracting it, so minus 50c. And then this still stays negative, so minus 125, and then equals 0. Okay? All right, so from there, we should look for a GCF of the entire problem. If there is no GCF, or if one just doesn't pop out to you, you can try moving on to the next step, which is to count the number of terms. There are 4 terms. We factor 4 terms by grouping. So I'm going to group my first 2 terms together. And then I'm going to group my second 2 terms together. Now I'm going to look for a GCF within each group, okay? So the GCF here is a 4c squared, which is going to leave me with a 2c plus 5. My GCF of the second group is a negative 25. When I factor out a negative 25, negative 50 divided by negative 25 is a positive 2c. Negative 125 divided by negative 5 is a positive 5. Well, just like for the last problem, at this step, I'm looking for a common binomial factor. My GCF is now the 2c plus 5 because that's what they have in common. So the GCF is a 2c plus 5. What's left when you pull that out? Well, from this term, I'm left with a 4c squared. And from this term, when I pull out the GCF, I'm left with a negative 25. Before you look and say you're done, check. Is there a GCF? Does this match a pattern? No. Is there a GCF? Does it match a pattern? There's no GCF, but it is a difference of perfect squares. So the first binomial stays the same. The second binomial factors to 2c minus 5 and 2c plus 5. Okay. Now I'm going to set each of those, I'm going to go back to red so I can see better. I'm going to set each of those equal to 0 and solve for c. So for the first one, subtract 5 and divide by 2. So you're left with c equals negative 5 halves. The next one, add 5, divide by 2. So c equals positive 5 halves. And then subtract 5, divide by 2, c equals negative 5 halves. Okay. There are the degree is 3. There are 3 solutions, but notice that this one repeats. So I wouldn't write it twice if I was giving my answer. I would just write it once. And what you can do, although I don't require it, some teachers do, I don't. If you put a DR, oh yeah, that's what I want to write. That stands for double root. I was getting confused because this book refers to it as a repeated solution, which is the same thing. But if you do DR, that stands for double root, meaning that this repeats, as we saw, right? I crossed it out over here, but it was a repeated solution. It appears twice, okay? And we're going to talk more about that in the next set of problems when we go to graph, because it does make a difference whether or not it's a repeated solution. All right. Okay, so we just have a few more. I think I have like 4 graphing problems that I wanted to work through. And that'll be it for, let me see how many. Yeah, 4 graphing problems. That'll be it for day 1. Okay, so here to find the zeros of the function, which in order to do that, oh, I wrote it down here. Find zeros by factoring. Yep, that's what I was going to write. Didn't realize I typed it. So you're going to find the zeros of the function by factoring, and then you're going to sketch a graph of the function, and we're going to sketch it without a calculator. Okay, so to find the zeros, we have to do what we did above. We need to set this equal to 0 and solve. Okay, so I'm going to start by writing 0 equals x to the 4th minus x cubed minus 12x squared. Look for that GCF. I have an x squared GCF. So when I factor that out, I'm left with x squared minus x minus 12. Try to break that trinomial into two binomials. Think of two numbers that multiply to negative 12, but add to a negative 1, which is negative 4 and a positive 3. Set each factor equal to 0. So I have x squared equals 0, x minus 4 equals 0, and x plus 3 equals 0. Solve for x, and you're going to be left with x equals 0. But remember, this is a double root, right? Because typically I would do plus minus the square root of whatever number, but 0 is not positive nor negative, but it does represent two solutions. It's a repeated solution. Add 4 to the other side, so x equals 4. Subtract 3, x equals negative 3. So just to kind of verify, this is a polynomial of degree 4, and I do have 4 solutions because this is a repeated one, so you can count this as like 1, 2, and then 3, 4. Okay, now in order to sketch, we have to talk a little bit more about the graph, but let me get my XY axis drawn up here. You can do it right in the middle. So here's my Y axis. Here's my X axis. Okay, so in order to graph, a few things we need to do. First, we can just plot the solutions. Those are the x-intercepts, the roots. So I'm going to plot a point, negative 3. 1, 2, 3. Here's one of the solutions. I'm going to plot a point at 0, and I'm going to plot a point at 4. Okay, now, this is just a sketch, but I do need to know the end behavior because I need to know, should my ends be down? Should ends be up? Should my ends be one up, one down, right? So I do need to talk about the end behavior. And then I'm going to talk about whether or not when you hit that x-intercept, are you going to go through it and go up or maybe go down, depending which direction, or are you just going to hit it and change direction? Okay, and that has to do with the degree of the factored form. All right, so first thing, let's talk about the end behavior. Oh, I'm going to have to erase some of this, but I don't want to erase it all. All right, so give me a second. Running out of room. I have to rewrite some of it off to the side, but just smaller. All right, so I'm just going to write the factored form. We had x squared, x minus 4, x plus 3 equals 0, and then our answers were x equals 0, x equals 4, x equals negative 3, and this was a double root, this one. Okay, so end behavior. We know from previous lessons to determine the end behavior, what we're going to look at is the degree and the lead coefficient. Okay, so since my degree is 4, which is an even number, we know that both ends are up or both ends are down because it models like a parabola, quadratic, right? Degree 2. My lead coefficient is going to tell me if both ends are up or both ends are down. My lead coefficient is a 1, which I don't really care about the number. I need to know is it positive or negative. It's positive, so both ends are up. Okay, so if both ends are up, I can at least start by going something like this. All right, both ends are up. Now I'm going to come over here to the factored form and to the solutions, and I'm going to use words. I'm going to use the words touch or pass. Okay, so you might want to write these notes down, and they'll hopefully make sense as I do the first example. You're going to look for the degree of each factor in factored form. So you're going to look at the factored form and look at the degree of each factor. And then what you're going to do is if the degree is even, that means that your graph, your line is going to touch at that point. If it is odd, you're going to pass. And again, this will hopefully make more sense when we look at the first example. All right, so this is the factored form of my polynomial function. This is a degree 2, right? That's even. So underneath the answer of x equals 0, I'm going to write the word touch. This factor, x minus 1, it's a degree 1, right? We don't normally write the exponent there, but it has a degree 1, which is odd, which means for this solution, I'm going to pass. This factor also has a degree 1, which is odd, so I'm going to pass. All right, so what does this pass touch mean? That means that when I go to 4 on the x-axis and when I go to -3 on the x-axis, I'm going to pass through that 0, that solution, all right? But when I get to 0, I'm just going to touch and change direction. So what I mean by that is here's -3. I'm going to pass through -3. I'm just going to go down a little bit. I mean, kind of is up to you. That's why it's a sketch. At some point, you have to start changing directions and going back up to the next 0. Now, for this one, I'm at 0 now. It says touch. That just means I'm going to touch and then instantly change directions and then start heading back up to the next 0. And for this 0, I'm passing through. So you can see that I pass through and keep going on. Okay, so that is a rough sketch of the function. If this touch pass didn't make sense this time around, stick with me and do like 3 more examples and hopefully it'll make more sense. Okay, all right, so let's move on to the next. All right, so I'm going to set it equal to 0, -4x cubed plus 12x squared minus 9x is equal to 0. I'm going to look for a GCF to start. There is a GCF of an x, and I'm actually going to factor out a negative x because, again, I don't like to have a lead coefficient that's negative. So when I factor out a negative x, I'm left with a positive 4x squared, a negative 12x, and a positive 9. All right. Then I'm going to try to break that trinomial into 2 binomials. This one's a little more challenging since I have a lead coefficient of 4, because I could have a 4 and a 1. I could have a 2 and a 2. So let's try 2x and 2x. And then for 9, it could be a 1 and a 9, a 9 and a 1, or a 3 and a 3. Let's just try 3 and 3. So when I multiply my outside terms, I get a 6x. When I multiply my inside terms, I get a 6x. If both are negative, that'll add to that negative 12x. So I know that I'm factored correctly and both get a negative. All right. Then from there, you're going to set each factor equal to 0 and solve for x. So I have negative x is equal to 0, 2x minus 3 is equal to 0, 2x minus 3 is equal to 0. So that's going to leave me with, oh, you know what? I want to write this a little bit differently. You could keep going this way. It's perfectly fine. But for the whole touch pass scenario, I want to actually write this a little bit differently. Notice how these 2 binomials match perfectly. 2x minus 3, 2x minus 3. So I can rewrite that as 2x minus 3 squared equals 0. That's going to help with knowing if we're supposed to pass or touch. All right, so set each factor equal to 0, negative x equals 0, and 2x minus 3 squared equals 0. So I have x is equal to 0. And over here, I'm going to take the square root of both sides. So I'm going to have 2x minus 3 is equal to 0 when I take the square root. Then add 3 to both sides. So 2x is equal to positive 3. Then divide by 2. So x is equal to 3 halves, which is 1.5, which might be helpful for graphing purposes. Okay. So my answers are x is equal to 0 and x is equal to 1.5 or 3 halves. Notice this is a double root of repeated solution because remember up here it appears twice, the same factor appears twice. So this represents 2 of your solutions. This is 1, it's degree 3, so that all makes sense. Okay. So when I look at the factor factored form, this factor has degree 1, okay? Odd degree. Are we going to pass when we get to that x-intercept? Okay, if it's an odd degree, you're going to pass. All right, this factored form has a degree of 2, which is even. So that means we're going to touch. All right. Last thing we have to talk about before we can graph is the end behavior. So for this polynomial function, it's degree 3, which is going to be either one arm up, one arm down, or I think I said that this way and wrote the other way. So one arm up, one arm down, or one arm down, one arm up. All right, the lead coefficient is a negative. So if the lead coefficient is negative, then it's going to take this shape here. Oh, nope, I drew it wrong. Sorry. That's not what I meant to draw. It's going to be this, no, it's going to be this one. Sorry, this one here. Because if you were to stretch this one out and make it look like a straight line, right? Like take this arrow and pull it up this way, take this arrow, pull it down, that would be a line with negative slope. All right, so this is the shape of my graph. That's the end behavior. And then I know if I'm touching or passing. So let's go ahead and graph this one. All right, so I have one x-intercept at 0, which I'm going to pass through. And I have one x-intercept at 1.5, which I'm going to touch. I know my end behavior, right? One end is up while the other end is down. All right, so for x equals 0, I'm supposed to pass through. So that means I go through it and I keep going down a little bit. But at some point, I'm going to have to start heading back towards the next x-intercept. For this one, it says I just touch it. So I touch it and quickly change directions, which agrees with what I said my end behavior was going to look like. So there you have it. All right, let's try another one. Okay, let's set this one equal to 0. 0 equals x cubed plus 4x squared minus 6x minus 24. There's no GCF, there's 4 terms, so I'm going to group it. X cubed plus 4x squared plus negative 6x minus 24. GCF of the first 2 terms is an x squared, so factor that out. I'm left with x plus 4. GCF of the next 2 terms is going to be a negative 6. So when I factor that out, I'm left with an x plus 4. My common binomial factor now is x plus 4. When I factor out the x plus 4, I'm left with x squared minus 6. No GCF, not a pattern. No GCF, not a pattern. I'm done factoring. I set factor equal to 0. I have x equals negative 4 as one x-intercept. Here I'm going to have x squared equals positive 6 when I add the 6. And then x equals plus minus the square root of 6. All right. So you may want to get a decimal approximation, which you could just pull up your calculator. I'm just going to tell you what it is because we need to know where to approximately plot them. Remember, these are sketches. So that's x is equal to approximately plus minus 2.5. Okay. Notice I have 2 solutions here, a positive 2.45 and a negative, and then one solution there. It's degree 3, and I have my 3 solutions. Okay. Now, in factored form, this factor has a degree of 1, and this factor also has a degree of 1. So they both have odd degree, and when there's odd degree, that means we're going to pass. Now, I just need to talk about the end behavior, and I can start graphing. So the end behavior, this is degree 3. When I have an odd degree, I know that I have one arm up, one arm down. So it's one of these two. My lead coefficient is a 1, which is a positive 1. So just like a positive line, if I take this arrow, stretch it that way, take this arrow, stretch it that way, it would look like a line with positive slope. So this is the shape of my graph. All right. So I'll make my X and Y axis nice and dark. For this one, there's one other thing I want to point out. One other thing that can help you get, more accurate graph, these are sketches, which is fine. If there's a constant, my other graphs didn't have a constant value, my other functions, I should say, so I didn't mention it. But if there's a constant, that's your y-intercept. So I could change my I could change my scale and count by maybe 5s, -5, -10, -15, -20, -25, and I could plot a point at approximately -24 to represent my y-intercept. Okay, and then my x-intercepts, my roots, my solutions are -4, 1, 2, 3, 4. Obviously, this won't be drawn to scale since I changed one scale, but not the other. And then a -2.45, about right there, and a +2.45, somewhere about there, okay? So I said that the ends should be one down, one up. So I go to the extremes and I put one arm down and one arm up. And for all of them, it says you pass through. So you pass through means you go through it, and then you're going to have to change directions at some point and come back down to the next x-intercept. So I'm going to pass through, right? I'm going to come back down to the next x-intercept. Now, because I have my y-intercept there, I'm going to go down to it and then start coming up to the next one, and I pass through it, okay? And there's your sketch. All right, last one. So I have 0 is equal to x to the 4th minus 18x squared plus 81. Looking for the GCF, there is no GCF. So then I try to guess and check, reverse FOIL. It's going to be x squared minus 9, x squared minus 9. All right, so that's going to be, because those are a difference of squares, both of them, x minus 3x plus 3, and then another x minus 3x plus 3. So in a more simplified way, since x minus 3 shows up twice, I can write it as x minus 3 squared. That's going to help me determine if I'm passing or touching, and x plus 3 squared. All right, so set each factor equal to 0, x minus 3 squared equals 0, and x plus 3 squared equals 0. I'm going to take the square root of both sides. Remember, typically I'd have plus minus 0, but 0 is not negative or positive, but that means that this is a double root of repeated solution. So this is a double root of repeated solution here. And I'm going to subtract 3 from both sides after taking the square root. So x plus 3 equals 0, and then x equals -3. This is a double root repeated solution. So I have 2 solutions, 4 total solutions, degree is 4. Okay. Oh, I got to talk about end behavior and pass or touch. All right, so this is degree 2 even, degree 2 even. So for both of them, I'm going to touch. My end behavior, end behavior. The degree is even, so it takes the shape of quadratic parabolas where both ends are up or down. My lead coefficient is +1, so I know both ends are going to be up. and also the 81 is your y-intercept. Lots to pay attention to. I already noticed Algebra 2, it's all about the details, right? You have to put a lot more thought and concentration into our problems than you probably ever had to in Algebra 1. Okay, so I think I had to count by 20s in order to graph 81. So 20, 40, 60, 80, 100. I'm going to plot my roots. I have one root at -3, one root at +3, and then I have my y-intercept at 81. Both ends are up. And I'm going to touch, so that means that I don't pass through it, I just touch it and quickly change directions. Now I have my y-intercept, so I'm going to go up to my y-intercept and then I'll start coming back down. And then again, I just touch and change directions. Okay. All right. I know that was a longer lesson, but I wanted to make sure to go through everything very thoroughly. So that is it for this lesson. I'll see you back here for day 2. Bye.